We'll start with the measurement of blood pressure. As you've possibly already seen the technique of blood pressure, I want to talk quickly about some of the physiology behind the actual measurement. So imagine yourself going to be taking a blood pressure and you're aware of the process. We put the sphygmomanometer or the blood pressure cuff on the person's upper arm. We place the stethoscope in the antecubital space, listening for our first carot cough sound. When you first place the blood pressure cuff on the person's arm, you place the stethoscope onto the artery, you're not going to hear any sounds. And that's because we have these red blood cells flowing through the open vessel in what we'll call laminar blood flow. The blood flow is rather unrestricted, and if this were to be the vessel wall of the artery, the red blood cells are flowing through this vessel rather unrestricted. So if we were to place this head of the stethoscope here, there's no sound that is being made by the red blood cells. But as you're aware, as you start to slowly inflate the cuff, we'll start to hear a slight tapping or knocking sound. Now, before you place the cuff on, we're at 0 millimeters of mercury. As you begin to increase the cuff pressure, let's say we've increased the cuff pressure up to 100 millimeters of mercury. Now these red blood cells that are traveling through this artery are encountering some resistance or impedance of their laminar flow. And so as a result, these red blood cells that were traveling rather unimpeded with no pressure in the blood pressure cuff, now we find that there's a slight occlusion or slight compression of this artery. So therefore, when these red blood cells make their way through this artery, we create more of a chaotic blood flow. We'll call this turbulent blood flow. Now, this turbulent blood flow is what initiates the tapping or knocking sound that you would hear when you listen through a stethoscope. As the red blood cell makes its way through this partially occluded vessel, it's going to bang around on the interior lumen of the vessel wall, creating that characteristic knocking sound. Now, you'll recall from the measurement of blood pressure, we need to ultimately get to a point where we have completely occluded blood flow through the artery. Now, let's say our participant had a blood pressure of 120/80. If we were to increase the cuff pressure to 140 millimeters of mercury, that would be adequate to completely occlude the vessel wall. And typically, after we have occluded the vessel wall, we'll increase the pressure about 20 millimeters of mercury more to ensure that we have, in fact, completely closed the arterial vessel. When we've closed the arterial vessel, you'll notice that these red blood cells, they are no longer able to travel through to the other side. This is where our head of the stethoscope would be. At this point, with the head of the stethoscope, we hear no sounds. It's at this point we're ready to begin the measurement of blood pressure. So as we begin to release the cuff pressure at 2 to 3 millimeters of mercury per second, we'll slowly begin to open up this arterial vessel. And as we begin to open up the arterial vessel and the first red blood cell is able to sneak its way through, this is going to create the first carot cough sound. As an example, I said that this patient had a blood pressure of 120/80. So if we get to 120, and this is where we hear our first sound, it's at this point that we would say that's our systolic measurement. Now, as we continue to release the cuff pressure, ultimately we release the cuff pressure to a point where these red blood cells are no longer in a turbulent blood flow, and they return to that characteristic laminar flow. At which point, the sound that we heard during that chaotic circular movement of the red blood cell, at which point that sound goes away, we'll call this our diastolic blood pressure. At this point in our blood pressure test, we would be able to record the systolic and the diastolic value and then completely deflate the cuff pressure. So let's go through this again. Let's remind ourselves. This is where we're at rest. We've placed the head of the stethoscope on the artery. We do not hear any sound. There's laminar blood flow. We begin to increase the cuff pressure to a point where it partially occludes the vessel, at which point we might start to hear a knocking sound. We want to continue to inflate the cuff pressure until that sound goes away. So let's say we get to 120 millimeters of mercury and that sound disappears. We want to continue inflating about 20 millimeters of mercury more to ensure we have fully occluded the vessel. So at this point we would stop at 140 millimeters of mercury. Now we're ready to begin the blood pressure test. Let's go ahead and start releasing the cuff pressure, 2 to 3 millimeters of mercury per second. And at some point, this vessel wall is going to begin to open up. As it does so, the first of our red blood cells are going to sneak through. And again, in this turbulent blood flow, they're going to knock around or bang around on the interior vessel wall. This creates our first Korotkov sound. Now, as we continue to release cuff pressure, ultimately that sound will become distorted or muffled. We'll consider that to be our fourth Korotkov sound. And it's when that sound disappears and the red blood cells return to that laminar flow, we would call this our diastolic pressure, or our fifth Korotkov sound. Let's take a look at another figure to help illustrate our point. Let's say we've already collapsed the arterial wall. Now you'll notice that in the example I provided, we had a blood pressure of 120 over 80. In this example, this person's blood pressure, we can see if we were to track the pulse pressure of the systolic and diastolic, this person would have a blood pressure of 130 over 80. So the technician here, when they got to 120, they still heard a sound. So they went up a little bit more, and they went up to 130. And finally the sound disappeared and they inflated, in this case, 30 millimeters of mercury more. That's okay. We definitely want to go at least 20 millimeters of mercury above where we heard that final sound, because we are ensuring that the artery is completely collapsed. Now at this point, there's no sound and we're ready to begin our trial. So we're going to start to release the cuff pressure at 2 to 3 millimeters of mercury per second. And as we get down to this point where that first sound is heard, do you see here, this is our first Korotkov sound. This would be, the green would be our stethoscope. The first Korotkov sound indicates there's a slight blood flow through the artery. This is our systolic pressure. Now, as we continue to release the cuff pressure, that sound gets a little bit louder as the artery becomes less restricted. At some point, that sound will become a little bit muffled and distorted, and that's what we see happening here. It's upon this muffling and distorting that we'll call this our fourth Korotkov sound. And as we release the cuff pressure below that diastolic pressure, the sound goes away. Now, when there's no arterial restriction, the blood flow is back to that rather streamlined laminar flow. No sound is heard. The sound has completely gone away. And at that point, we would consider this to be our diastolic pressure. And that's what we see happening here. Once that sound has gone away, we've now achieved our diastolic pressure. So if we were to measure this, we first inflated the cuff up to 160. We began our test. The first sound occurred. Now, when the first sound occurred, we considered that to be our systolic pressure. The sound gets a little bit louder as the vessel continues to open. The sound distorts and muffles. That's phase 4, Korotkov 4. And as that sound goes away, the 5th Korotkov sound is heard. There is no arterial restriction. We'll consider this to be our diastolic pressure. So that's, in theory, that's the fundamental method of measuring blood pressure. We want to now look at our Biopac data to analyze some sample data from some measurement of blood pressure. In this example, I'm going to be using Wendy's Lesson 16 data set. And as I open up Wendy's data, you'll see a series of different trials that were measured. I first want to draw your attention to these diamonds at the top. So the first diamond, if I hover over it, it indicates that this was the left arm, the first seated measurement. As I hover over this second dot here, you can see that this was the left arm, the second measurement. This next trial in here, this would be the right arm, first measurement. The next trial here, this was the right arm, the second measurement. Our next trial would be the right arm supine, first measurement. The right arm supine, this is lying down, first measurement. And finally, the right arm post-exercise, and that's this final set of data that you see here. Okay, so now we're looking at our data set. We want to now analyze the data that we've collected. So if we look at our procedure document, we can see there's a number of different trials that are going to be conducted, and we have our measurement of blood pressure connected to the Biopac. We have our stethoscope connected to the Biopac. We also have the ECG leads connected to the Biopac. So we're going to be using all of these as we do our measurement of blood pressure. Again, if you recall the EKG measurement, we'll have our electrodes placed in the configuration that we used for measuring electrocardiography. That person will be set up. We'll be looking at electrocardiography on the screen in just a moment. As we continue down, you'll notice that as we go through the measurement of blood pressure using the Biopac, you'll have a digital scale that appears on the screen. This is how you'll know what your blood pressure or the cuff pressure is. You'll go through your calibration process, make sure your stethoscope works, make sure you're getting a reading. Now, very important here as we go to measurement the brachial artery, we'll find the brachial artery here. We can palpate that. It's on the interior or inside of the upper arm, just under the belly of the bicep. We'll place the cuff a couple of inches above the bend in the elbow, and then our stethoscope can go directly above the brachial artery. So we are in a good position. We're now prepared and we're set up now to do our measurement. One thing to note here is as you put the earpieces of the stethoscope into your ears, you may need to rotate them slightly forward so that they go into the ear canal, and it also might be a little bit more comfortable, and you'll be able to hear the sound perhaps a little bit better. Okay, we get into our measurement of blood pressure, and you're gonna notice that we do the same process multiple times. We're going to be putting in event markers to indicate when we heard the Korotkov sound appear. So you'll notice that we're going to use these event markers. If the event markers are missing when you do your test, that means the system didn't record them, so you need to make sure that you redo that trial. But ultimately, when you press F4 and F5, this will give us these event markers that you see up here at the top of the screen. That gives us an indication of when systolic blood pressure was heard, that first Korotkov sound, and when diastolic blood pressure was heard, that's our 5th Korotkov sound. So as we go through our test, you'll complete all 5 trials. We'll go through our right arm seated, and then we'll make sure we do our right arm supine, and then we'll complete finally with our exercise value. Now, as we go into the measurement of, or the analysis of our blood pressure, you're going to see a number of different trials that we need to measure. So a moment ago, I think I said 5 trials. Let me clarify and say there are 4 trials. The left arm seated, the right arm seated, the right arm lying down or supine, and then the right arm post-exercise. So this is what you're going to use to complete this week's data sheet. And we'll walk through this step by step as we go forward. But we'll start with an example of the left arm, and then we'll go through the first trial just so you'll know what values to put in. Now here, when you analyze the first trial, you analyze the second trial. This is just recording the difference between the two. And then box A here, let's say that this was 120, this was 122. We would take the average, so you'd put 121. If this was 120, this was 122, the difference would be 2. Okay, so we'll put in our value for the left arm seated. Then we'll average the pressure. Now this will be the systolic, just so we're on the same page. Then we're also going to measure the microphone detected pressure for the systolic. And we'll calculate that. And then this is really actually a pretty fun part of this experiment or trial, because we get to determine at what point your ears detected the sound versus when the sound actually occurred from the microphone. So the microphone is very, very sensitive. The microphone can pick it up, whereas your ears may be a little bit less sensitive. So we want to know what's the difference between when the microphone first detected the signal to when you actually put in your event marker and you calculated the signal. Let's start here with measurement of systolic pressure. We're looking for one value. Okay, so as we come into our set of data, I'm going to grab onto this magnifying glass over here. I'm going to zoom in on our first set of data. So this here would be the first set of data. In this case, if I click on this dot, it says left arm seated first trial. So now we're ready to begin our experiment. So again, if we come to this dot here, if I click on this, this tells me when the F4 and F5 were pressed. This is the recording for systolic. So I've put my cursor here and I've highlighted right at that red dot. And once I'm now at this red dot, I can now look up here and get the one value. So from this measurement, we determined that the systolic pressure was 112.91. So that 112.91, we record that on our data sheet. This would be for systolic first trial. So I need to go to the next section to measure systolic second trial. Before I go away from the first trial, let's measure the microphone detected pressure. So here we'll find our microphone detected pressure. Now in this case, you can see very clearly that there are a lot of just kind of erroneous values, very, very small green marks that don't really correspond to anything. But then you'll notice that there's some small green marks, and then our first prominent or more pronounced green line. Right there is when the microphone first picked up the sound. The stethoscope picked up the first sound. Now, you'll notice that the value the stethoscope picked up is 115.47. So if I plug that back into my chart, 115.47, I now have my audibly detected pressure event from the first trial. I have my microphone detected event from the first trial. I then would go on to the second trial. So to do that, I can go display auto scale horizontal. This takes me back to this big screen. Again, if I click on this dot right here, this will show me this is my left arm, the second trial. So now I have my microphone or my magnifying glass highlighted. I'll zoom in on this second set of data. And at this point, I would then calculate where my cough sound occurred. Let's say 111.56. So we'll plug that in, 111.56. You then can compute the difference, type that value in here, compute the average, type that value in here. We would do the same thing to get our microphone detected value from this second trial, and then we would plug in the average. Then we'll take the difference, okay, between the average of pressure B, that would be this value here, and the average of pressure A, that would be this value here, and we'll determine at what point the microphone picked up on the trial compared to when your ears heard the trial. So that would be our measurement of systolic pressure for trial 1, trial 2 for the left arm. You also want to do this for diastolic pressure. Now, obviously, it's going to be very similar. Audibly detected pressure, trial 1, trial 2. So if I go back to my Biopac data, you'll notice that I'm currently on trial 2. We probably could have done diastolic, but we've already done systolic for part 2. So I'll go ahead and find, again, if I click on this dot here, that shows that this is my diastolic. I've clicked on this line. I've got 88.44. So we would say our diastolic for part 2, 88.44. Now we'd have to go back to part 1 to get the left arm first trial. Again, we'll do our microphone for the first trial, microphone for the second trial, and determine when we calculated those. Okay, so that's the strategy to measure your difference in systolic and diastolic. Then you're going to have your measurement of beats per minute. You're going to use your 3 cardiac cycles. Obviously, to do this, we're going to use our blue data. That would be our ECG data. We're going to look at 3 BPM to do so. So if we go into this segment here, at the point where our systolic value occurred, actually I'll just go back so we're on the same page. Let's go auto scale horizontal. We'll go to our first set of data. I've grabbed the magnifying glass. I'm going to zoom in on my first set of data. And now we want to know when our systolic pressure occurred, what was the beats per minute. So to do that, I've found my systolic marker. And now I want to know, following that systolic measurement, what was my beats per minute? So if I measure from, we can even zoom in here on this set of data. Display auto scale waveform. Right here was our systolic data. So we want to measure from the R wave to the R wave. This would be cardiac cycle 1. 3 beats per minute, 3 BPM, is 78.12. So we would say 78.12. Again, I would calculate my second trial, 77.12. And we would do that for, again, the third trial. So this would be for the third cardiac cycle for the first blood pressure trial. Then we'll go back, we'll find the left arm seated, we'll do the blood pressure or beats per minute from the second blood pressure trial. Again, we're going to calculate the average of these 3, and then the mean of both trial 1 and trial 2, and we'll plug that mean into here. So we'll do that for all of our values: left arm, right arm lying down, and right arm after exercise. You've then got this value to calculate. You've got some equations here to calculate mean arterial pressure at rest and mean arterial pressure during exercise. You'll notice that we use some slightly different equations, and the reason that we use those slightly different equations is because during exercise the heart spends proportionally a little bit less time in diastole than it did during rest. So as a result of our change in the time spent in diastole, we use a slightly different equation. So we would use mean arterial pressure for all of our resting values. We'd use this equation divided by 3. We would use this equation where we have 2 times the diastolic pressure divided by 3 for all of our exercise trials. So again, you'll record your mean arterial pressure using those equations. Your pulse pressure is calculated by systolic minus diastolic. We'll plug in our values from table 16.2 using the sound average above, and our beats per minute from table 16.4, and that's how we'll calculate this value. Then we can calculate the timing of these Korotkov sounds. So this table requires ECG data. which we have in our data set. So we'll be able to do this looking at the timing of the croak cough sounds using this 1 delta T measurement. So in your procedure sheet, you'll notice that there's figure 16.29 indicating how it is that you measure the timing of that croak cough sound. So again, we want to measure the timing of the croak cough sound at that systolic mark. So let's go ahead and find that in our data sheet. So here this would be, again, I'll go back so that we're all on the same page of where we're at. Display auto scale waveforms. We're going to zoom in here on our first trial of blood pressure, and we want to find now our systolic measurement, which would be right here. So I want to zoom in on some of these waveforms here. So this would be when our systolic measurement occurred, and now we want to know our measurement of the croak cough sound. So as we first heard our sound here, we can take the following R wave, the next R wave that occurred, and we can now go to the very beginning of this first heart sound here. It's at this point that we're going to use our 1 delta T measurement. This would be 0.326 seconds. So again, we would plug this in, 0.326 seconds. This would be for the left arm seated first trial. Again, we would do this again, left arm seated for the second trial, and then we would calculate here our mean or the average of those two. Now, in this example, I will be providing some measurements, and that will be available to you on Blackboard so that you're able to calculate the pulse speed. So be sure to look on Blackboard for the data for the participant that you will be using. That'll be, you'll plug in that data here, you'll then complete your calculation, and we can then determine speed of the pulse as blood flow is traveling through the body. You'll then have a series of discussion questions which we'll answer, and you'll save your document and submit that on Blackboard. So if you have any questions, please don't hesitate to reach out. But everything that you need should be available here within the Biopac student procedures, within the analysis section, and then also using your Biopac data is how you will be able to complete all the measurements for each of those tables.